Hello everyone. Welcome back to my channel and this is Lekana. Today I'm here with a topic that is called as finite automata. It's a topic in theory of computation. In this video, I'm taking one research paper and I'm explaining that how they are contributed in this research paper. My topic is finite automata. In this video, we'll learn what is finite automata and the types of finite automata and applications of this and the theories which can be used to write this finite automata. Everything we'll learn in this video. Now we have introduction to finite automata. In this, first we have mathematical models, and the finite automata serves as a mathematical model for computation. And second we have design applications. This finite automata, they are utilized to design computer programs and sequence logical circuits. And third we have finite states. The structures consist of finite number of states and transition. This finite automata, while doing the problem, we'll learn in the upcoming slides. In this finite automata, it consists finite number of states and transition. Next we have input processing. Finite automata defines rules for accepting and rejecting input strings. Next we have types of automata. In this there are mainly two types of automata, that is deterministic finite automata, which is also known as DFA in the short form. Next we have non-deterministic finite automata, which is known as NFA in the short form. Application area. They are crucial for the applications in compiler design, network protocol and artificial intelligence. Next we have types of finite automata. We have that we studied in the last slide. There are two types of finite automata, that is DFA and NFA. We'll see what's the definition of this two types of automata. First we have DFA. Each state in DFA has exactly one transition from each symbol of the alphabet, ensuring a single path for input processing. Then next we have NFA. NFA allows multiple transition for the same symbol, including epsilon transition, enabling flexibility in state transition. What is the key difference between this DFA and NFA is, while NFA can be more intuitive to design, they require conversion to DFA from implementation, which is often more efficient in practice. And next we have theory foundations of finite automata. Which are the theories we have in doing this finite automata? Models for regular languages. Finite automata serves as a foundation models that defines and recognize regular language. Next we have Church-Turing thesis. This thesis persists that any computation can be executed by Turing machine, established a link between finite automata and border computation. Next we have DFA and NFA equivalence. The fundamental theory in automata theory confronts the equivalence between deterministic finite automata and non-deterministic finite automata. Next we have how we'll convert this NFA into DFA. We use subset construction method while solving manually. First we should identify the initial state of the NFA. In that, recognize the starting point in the NFA for actuating start conversation. The starting state is represented with the arrow mark. Next point, determine all the possible transitions for each state. We should determine all the possible transitions from each states. Map out all transition to understand the NFA behavior. Next, we should establishing states in a DFA that encompass multiple NFA states. Create DFA state that combine multiple NFA states for efficiency. Next, we have efficient execution using programming language like Python. In Python language, we can use this conversion of NFA to DFA, utilizing programming language for implementing this conversion process effectively. Next, we have algorithm approaches to finite automata. What are the algorithms we can approach to this finite automata is, one is subset construction algorithm. Next is Hopcroft algorithm. Next we can use the Python implementation. In subset construction algorithm, a systematic method that captures all transition from NFA to DFA, ensuring a comprehensive transformation. In the Hopcroft's algorithm focuses on minimizing DFAs efficiently, optimizing the performance of finite automata. Next, we have Python implementation, utilizing libraries such as pandas for constructing transition table, enhancing usability and efficiency in automata. Next, we have applications of finite automata. The first application is compiler design, and second we have network protocol, and third artificial intelligence, and fourth content aware applications. In first, compiler design, tokenization and syntax checking utilizes DFA to recognize the structure of programming language. In the network protocol, finite automata are employed for parsing messages, ensuring correct communication in networking system. Third, we have artificial intelligence. In artificial intelligence, finite automata are used for pattern recognition and natural language processing tasks, enhancing machine understanding. And fourth, we have content aware applications. These applications utilize finite automata to identify or filter content based on predefined rules, improving user experience. Next, we have the last. What are the challenges in the finite automata theory? First, we have complexity of conversion. Converting large scale NFAs to DFA can lead to exponentially more states, complicating analysis. Next, we have human error. Manual conversions are prone to errors, particularly with the complex NFAs, leading in inaccuracies. Third, we have performance in efficiency. Deterministic models may suffer from inefficiency in certain scenarios, implementing overall performance. Next, we have the future directions in the automata theory, in which areas this automata is playing a very important role in the future directions. We can see in the integrating with the machine learning and with the mobile and web application, advanced automata. In these fields, this finite automata theory will give a big impact in the future. Next, we have what are the key factors, key takeovers, what and all we have learned in this video is DFA2, and what are the definitions between the DFA and NFA, understanding the distinction between DFA and NFA, and highlighting their respective advantages in the automata theory. Then conversions theory, we used three theories, algorithms in this conversion, exploring the importance of conversation algorithm for effective applications of computation task. Next, we have future prospects, discussing ongoing research and the future prospects in the automata theory, focusing on the computation efficiency and the real world applicability. Thank you for watching my video.